The Wasatch Range rises abruptly from the valley floor east of Salt Lake City, a wall of granite and limestone that catches weather systems moving across the Great Basin. In the winter of 1982 and 1983, those mountains became a reservoir of frozen water on a scale the region had not witnessed in recorded history. Storm systems moved through Utah beginning in November. Snow fell steadily through December. January brought more. February continued the pattern. Each system deposited layers across the high country, building depth in the canyons and on the peaks. Ski resorts reported measurements exceeding their operational records. Weather stations in the mountains recorded snowpack depths approaching 6 meters in some locations. Below in the valley, Salt Lake City functioned as it always had. Commuters drove to work. Children attended school. The mountains wore their white cover as they did every winter, beautiful and distant. Few residents considered what volume of water was being stored above them in crystalline form. March arrived with temperatures that remained cold. The snowpack held. April began the same way. Then the weather pattern shifted. A high-pressure system settled over the Great Basin in late April, bringing sustained warmth to elevations that had remained frozen for months. Temperatures climbed into the 20s Celsius in the valley. In the mountains, the air warmed enough to begin melting snow at depths that would normally remain frozen until late June. The process accelerated. Warm winds moved through the canyons. Sunlight struck south-facing slopes. The snowpack, compressed and dense from months of accumulation, began releasing water. Small streams that typically ran clear and modest in spring turned brown with sediment. Trickles became flows. Flows became torrents. City Creek, which descended from the mountains through a narrow canyon northeast of downtown, began carrying water at rates the watershed had not channeled in living memory. The creek normally ran through a concrete channel designed decades earlier based on historical flow data. Those records had not anticipated a winter like 1983 or a spring melt occurring this rapidly. By the end of April, the creek was running at nearly 10 cubic meters per second. Early May brought warmer nights. The melt no longer stopped after sunset. Water continued pouring from the mountains around the clock. The flow rate doubled. Then it doubled again. On the valley floor, residents noticed. The sound of rushing water became audible in neighborhoods near the creek. Spray rose where the water hit concrete barriers. City engineers monitored the flow with increasing concern. The channel system was approaching its design capacity. Then it exceeded it. Small streams throughout the valley behaved similarly. Red Butte Creek swelled. Emigration Creek ran bank to bank. Parley's Creek threatened homes built near its path. Every drainage from the Wasatch carried more water than its channel could contain. The soil in the valley, dry from winter, absorbed what it could. Then it saturated. Water began pooling in low areas. Storm drains designed to handle rainfall backed up as snowmelt overwhelmed the system from above and below simultaneously. City Creek continued rising. The concrete channel, built in the 1950s to contain spring runoff, groaned under the pressure. Water began overtopping the edges in places where the channel narrowed or where debris had collected. City crews worked to clear obstructions, but the volume kept increasing. By mid-May, the flow exceeded 20 cubic meters per second. The channel shuddered. Water found cracks in the concrete and exploited them. Sections began to fail. On May 18th, a portion of the channel wall near the mouth of the canyon collapsed. Water that had been confined suddenly spread across a wider area, seeking any downward path. It found streets. It found parking lots. It found the grade that led toward the city center, the creek, transformed by snowmelt into something far larger than its name suggested, began moving beyond human control. It was no longer following the path engineers had designed. It was following gravity and the ancient topography buried beneath pavement and buildings. The water was returning to routes it had traveled before the city existed, before streets were laid, before anyone had attempted to contain it within concrete walls. The Wasatch Mountains form the eastern boundary of the Salt Lake Valley through a process of tectonic uplift occurring over millions of years. The range rises steeply, creating watersheds that drain rapidly. City Creek's watershed covers approximately 40 square kilometers of steep terrain. Under normal conditions, spring snowmelt from this area flows gradually over several weeks. In May 1983, the melt was not gradual. The record snowpack released water faster than the watershed could regulate it. Soil that would normally absorb moisture remained frozen at higher elevations. Snowmelt ran directly into streams rather than percolating through ground. The runoff concentrated quickly. City Creek's natural channel through the canyon could carry perhaps 15 cubic meters per second before overflowing. The concrete improvements built downstream increased capacity to approximately 20 cubic meters per second under ideal conditions. By May 20th, the creek was channeling an estimated 30 cubic meters per second, with projections suggesting the rate would increase further. The mathematics were simple. More water was arriving than could be moved through the existing system. The excess had to go somewhere. City engineers understood this. Emergency meetings convened. Options were evaluated. Pumps were brought in to redirect water. Temporary channels were excavated in parks and open ground to spread the flow. Sandbag barriers were positioned to protect critical infrastructure. These measures helped at the margins but could not address the fundamental problem. The volume was too great. The system was designed for a different scale of event. On May 21st, additional sections of the concrete channel failed near Memory Grove, a park at the mouth of City Creek Canyon. Water spread across the park grounds, submerging pathways and lawns. It continued downhill, following the slope toward the city center. Salt Lake City's downtown occupies relatively flat terrain, but subtle grades exist. Water, even moving slowly, will follow these grades. City Creek's historical course before urbanization ran roughly north-south through what became the downtown area, eventually reaching the Jordan River several kilometers away. The storm drain system was connected to this topography. Drains that normally carried rainfall away from streets became conduits for creek water moving in reverse. Water rose through grates and manholes. It emerged onto streets from below and flowed from above simultaneously. State Street, the city's main north-south arterial, occupies ground approximately 3 meters lower than the terrain immediately to the east. This made it a natural channel for any water moving south through downtown. By the evening of May 21st, water was visible on State Street near South Temple, the northern edge of the downtown commercial district. City crews attempted to divert the flow using sandbags and plywood barriers. The water found gaps. It pushed through. It moved around obstacles. By midnight, a thin sheet of water covered 2 blocks of State Street. The flow increased overnight. More snowmelt arrived from the mountains. The creek channel remained breached. Water continued seeking the lowest path available. By dawn on May 22nd, State Street had water flowing along its length for approximately 2 kilometers, from South Temple south past 900 South. The depth varied. In some blocks, it measured only a few centimeters. In others, where debris created temporary dams, it pooled to 30 centimeters or more. The transformation happened gradually enough that evacuations could proceed without panic, but rapidly enough that residents and business owners struggled to protect property. Furniture was moved to upper floors. Merchandise was carried to high shelves. Sandbags were stacked against doorways. The water kept coming, not in a sudden wave, but in a steady, relentless increase. Morning became afternoon. Afternoon became evening. The flow did not stop. By nightfall on May 22nd, State Street carried a river where a road had been. The water moved at walking pace, brown with sediment, reflecting streetlights and neon signs. The sound of it filled the downtown district, a constant rushing that replaced traffic noise. It would continue for weeks. The evening of May 22, 1983, brought temperatures in the mid-teens Celsius to downtown Salt Lake City. Streetlights came on as usual. Office workers departed buildings as usual. The city's rhythm continued, but the streets themselves had changed. Water covered State Street from curb to curb in most blocks. The depth remained relatively shallow, mostly between 15 and 30 centimeters, but the breadth was striking. A main thoroughfare normally carrying vehicles now carried meltwater from the mountains moving steadily southward. The water was not clear. It carried sediment from the canyon, giving it a brown opacity that made the depth difficult to judge. It carried debris as well: branches, leaves, plastic containers, anything light enough to float. The surface moved in slow, steady patterns, swirling around obstacles, forming eddies near storefronts. The sound dominated the sensory experience. The rush of moving water, constant and pervasive, echoed off building facades. In quieter side streets, you could hear individual currents and flows. On State Street itself, the sound merged into a sustained white noise that made conversation difficult. Volunteers worked through the evening constructing barriers. Sandbags were stacked in configurations designed to redirect flow away from building entrances. Plywood sheets were wedged into door frames. Plastic sheeting was taped across thresholds. The work continued under artificial light as darkness settled over the valley. Some barriers held. Others failed as water found weak points or as the depth increased beyond what had been anticipated. Volunteers rebuilt them. Engineers adjusted plans. The work became cyclical: build, observe, repair, rebuild. Store windows along State Street reflected the scene. Inside, merchandise sat on raised platforms or had been removed entirely. Outside, water flowed past displays designed to attract pedestrians who could no longer reach them. The juxtaposition created surreal imagery: mannequins behind glass standing above moving water, neon signs advertising businesses that were temporarily inaccessible. The pressure against windows was measurable. Shopkeepers placed additional supports against glass panes. Some windows cracked from the force, requiring emergency boarding. Others held, vibrating slightly as water pressed and released in rhythm with changes in flow rate. Traffic was prohibited on flooded sections. Barricades closed State Street to vehicles from South Temple to 900 South. Side streets feeding into State Street carried water as well, though generally less. The entire downtown drainage pattern had been altered by the volume moving through. Residents in low-lying areas east of State Street received evacuation notices. Some left immediately. Others remained, moving belongings upstairs and monitoring water levels. Emergency services maintained presence in affected neighborhoods, ready to assist if conditions worsened. The night passed slowly for those watching the water. Flow rates fluctuated slightly but did not decrease significantly. Measurements taken at various points confirmed what observers could see. The situation was stable but not improving. The snowpack in the mountains continued melting. Water continued arriving downtown. Around midnight, light rain began falling in the valley. It was brief, less than half an hour, but it added to the complexity. Storm drains, already overwhelmed, could not handle even modest rainfall. Water pooled in intersections and on sidewalks, merging with the flow from City Creek. By 2:00 a.m. on May 23rd, the downtown district had settled into a strange equilibrium. Water flowed steadily along State Street and adjacent areas. Barriers held where they could. Pumps operated continuously, moving water toward the Jordan River. Volunteers rotated shifts, maintaining watch over critical points. The city was not in crisis exactly. Structures remained sound. No lives were lost, but normal function had ceased in a significant portion of downtown. The commercial heart of Salt Lake City was cut off, accessible only on foot through shallow water or via detours that added considerable distance. Above the city, invisible in darkness, the snowpack continued its transformation. Warmth stored in the mountain rock released slowly through the night. Small streams merged into larger ones. The water moved Downcanian toward the valley, joining the flow that had already breached the channel system. Morning would bring assessment of the night's changes. Daylight would reveal the full extent of what had occurred. But in the dark hours of early May 23rd, the immediate reality was simple and strange. A river flowed through Salt Lake City's downtown, and no one knew when it would stop. But in the dark hours of early May 23rd, the immediate reality was simple and strange. A river flowed through Salt Lake City's downtown, and no one knew when it would stop. By May 24, 1983, the transformation of downtown Salt Lake City was complete. State Street, for a length of approximately 2 kilometers, functioned as a waterway rather than a roadway. The flow had stabilized at depths ranging from 20 to 40 centimeters, depending on location and accumulated debris. The city adapted to circumstances it had not planned for and could not immediately resolve. The water would recede only when the snowpack finished melting or when temperatures dropped enough to slow the process significantly. Forecasts suggested neither would occur soon. The adaptation, therefore, needed to accommodate weeks, not days. Wooden footbridges appeared across State Street, constructed by city crews and volunteers. Simple plank structures, elevated above the water on concrete blocks or sandbags, they allowed pedestrians to cross from one side to the other without wading. The bridges were not elegant, but they were functional. People used them constantly. Businesses along State Street faced decisions about operation. Some closed temporarily, accepting the loss rather than attempting to function in flooded conditions. Others remained open, serving customers who entered from upper floors via connected buildings or who were willing to wade through shallow water to reach entrances. The reality of commerce in these conditions was challenging. Merchandise on ground floors was removed or elevated. Electrical systems required inspection and sometimes modification to prevent hazards. Foot traffic decreased dramatically even where access remained technically possible. The economics did not favor staying open, but some proprietors continued anyway, maintaining presence partly from necessity and partly from determination. Small boats appeared on State Street within days. Inflatable rafts, canoes, and small aluminum fishing boats were launched from curbs and used to navigate the deeper sections. The boats carried supplies, transported people unable or unwilling to walk through water, and served as platforms for documenting the situation. Photographers captured the scene extensively. Images from this period show downtown buildings rising from flowing water, pedestrians on improvised bridges, boats gliding past storefronts. The photographs have an otherworldly quality, showing a modern American city transformed into something resembling a canal district in a different century. The water was cold, typically between 8 and 12 degrees Celsius. It came directly from snowmelt, carrying mountain temperatures to the valley floor. Wading through it for more than a few minutes caused discomfort. Prolonged exposure risked hypothermia. People who needed to move through flooded areas regularly wore rubber boots or waders. The flow rate was strong enough to knock a person over if they lost balance. Several individuals did fall, though no drownings occurred in the downtown area. Emergency services responded to exposure cases and minor injuries, but managed to prevent major casualties. Debris accumulated at constriction points. Sandbag barriers intended to protect buildings inadvertently created dams where floating material collected. City crews worked continuously to clear these accumulations, using rakes, shovels, and occasionally front-end loaders when access permitted. The sediment load in the water gradually deposited on streets and sidewalks. A layer of fine silt built up, thickest in areas where the flow slowed. This material, carried from the mountains, covered downtown surfaces in brown-gray coating that would remain visible even after the water receded. Residential areas east and southeast of downtown experienced flooding as well, though conditions varied by elevation and proximity to drainage channels. Basements filled with water throughout a wide swath of the city. Some homes became uninhabitable. Residents moved possessions, then themselves, to higher ground or to accommodations with family and friends. The broader Salt Lake Valley faced similar challenges at multiple locations. Parley's Creek flooded neighborhoods along its course. Red Butte Creek damaged homes near the University of Utah. The Jordan River, receiving all the excess flow from valley streams, rose to levels that threatened levees and required constant monitoring. State Street remained the most visually dramatic example because of its location and length. A continuous waterway through the city center created imagery that was both striking and disorienting. The scale of the alteration made the event memorable in ways that flooded basements and damaged homes, though more common and individually significant did not. By the end of May, the situation had become routine in its strangeness. Downtown adapted. Businesses operated where possible. Pedestrians used bridges. Boats moved along State Street. Engineers refined pumping operations and drainage modifications. The city functioned, differently but continuously. The mountains continued releasing water. The creek continued exceeding its capacity. The flow continued through downtown. Days passed, then weeks. June arrived with warmer temperatures that accelerated melting at the highest elevations, bringing a second surge of flow just as the initial volume was beginning to decrease. Salt Lake City had become, temporarily, a place where a river ran through the commercial district. It was factual, documented, and surreal. The water moved past buildings that had stood for decades without contemplating their relationship to running water. Now they did, their foundations submerged, their purposes temporarily altered by hydrology that predated their construction. The turning point came not in a single day but across several weeks in mid-June 1983. Temperatures in the valley remained warm, but the pattern of overnight cooling strengthened. Lows dropped into single digits Celsius. At higher elevations in the Wasatch Range, this was sufficient to slow snowmelt during nighttime hours. The effect was gradual but measurable. Flow rates in City Creek, which had remained above 20 cubic meters per second for nearly a month, began decreasing. By June 20th, the rate had dropped to 18 cubic meters per second. By June 25th, it measured 15. The decline continued into July. The snowpack at the highest elevations was finite. Despite its record depth, it could not melt forever. By early July, much of the accessible snow had already converted to runoff. What remained existed in shaded cirques and north-facing slopes where melt rates were naturally slower. The peak of the crisis had passed. On State Street, the change was visible in increments. Blocks that had held 25 centimeters of water saw it drop to 20, then 15. Curbs began emerging from the flow. Debris lines on building walls marked the high water point, now above the current level. The city began recovery operations before the water fully receded. Pumps that had been running continuously for weeks were repositioned to accelerate drainage from low points. Storm drains, once the flow decreased enough, were cleared of accumulated debris. Engineers assessed damage to the concrete channel system in City Creek Canyon, identifying sections that required immediate repair and others that could wait. The removal of sandbag barriers started in early July. Thousands of bags had been placed throughout downtown and residential areas. They were collected, inspected for reuse, and eventually removed by city crews and volunteer groups. The process took weeks. Long after State Street dried, sandbag walls remained visible in less critical locations. Beneath the water, mud had accumulated. As the flow receded, this became apparent. A layer of sediment, sometimes several centimeters thick, covered streets and sidewalks throughout the affected area. The material was fine, slippery when wet, and difficult to remove. It had worked into cracks, settled in doorways, and penetrated building interiors wherever water had entered. Street cleaning operations began immediately. Water trucks and sweepers worked block by block. The mud, once dry, could be swept or blown away, but drying took time. In shaded areas or where pooled water remained, the sediment stayed wet for days after the main flow ceased. Business owners cleaned their properties. Floors were hosed, scrubbed, and hosed again. Carpets were removed if they could not be salvaged. Drywall that had absorbed water was cut out and replaced. The work was tedious and expensive. Insurance covered some costs, owners absorbed others. Residential areas faced similar challenges. Basements that had flooded required pumping, cleaning, and drying. Mold became a concern in buildings where moisture persisted. Structural inspections revealed foundation damage in some homes where water had eroded soil or exploited existing weaknesses. The road surface itself required attention. Pavement that had been submerged for weeks showed deterioration. Asphalt softened by constant water flow had developed ruts and depressions. Entire sections of State Street needed resurfacing. The work was scheduled for late summer after ensuring the flooding would not return. Engineers and city planners conducted extensive reviews. The flood had exposed limitations in infrastructure designed for a different climate regime. Storm drain capacity was insufficient. Channel systems were undersized. Floodplain maps required updating. Building codes needed revision to account for higher water levels than previously modeled. Recommendations emerged. Increase channel capacity in City Creek and other drainages. Construct retention basins to hold excess runoff. Improve coordination between meteorological forecasting and emergency management. Establish clearer protocols for evacuation and flood response. Some recommendations were implemented within months. Others took years. The memory of 1983 influenced urban planning in Salt Lake City for the following decades. New developments considered flood risk differently. Infrastructure projects incorporated larger safety margins. By August 1983, State Street was dry. Traffic resumed. Businesses reopened or closed permanently depending on their ability to recover financially. The wooden footbridges were removed. The boats that had navigated downtown were returned to storage or their original recreational uses. The city returned to normal function, but the event remained in collective memory. Photographs preserved the imagery: a river through downtown, boats on Main Street, water flowing where vehicles should be. The documentation ensured the event would not fade into obscurity. The Wasatch Range continued its presence on the eastern horizon, holding snow each winter, releasing water each spring. The relationship between mountain and city had been clarified by the flood. Salt Lake City existed at the mercy of hydrology it could moderate but not control. The creek itself was re-engineered. Channels were widened and reinforced. Concrete walls were replaced with stronger designs. Capacity increased significantly. The work aimed to prevent recurrence, though engineers understood that nature operates beyond predictable bounds. Residents who experienced the flood spoke of it with a mixture of disbelief and respect. The surreal quality of seeing downtown transformed into a waterway left an impression. The event demonstrated that beneath the urban surface, older patterns persisted, waiting for conditions that would allow them to reassert themselves. The 1983 flood was not the result of extraordinary rainfall or a sudden dam failure. It was simply snowmelt, arriving faster and in greater volume than the built environment could accommodate. The ordinariness of the cause made the event more unsettling in some ways. It could happen again if conditions aligned. Salt Lake City had been reminded of its location at the base of a steep mountain range, in a valley shaped by ancient lakes and rivers, on ground that had been underwater before and might be again. The city continued, adapted, and prepared as best it could. The creek returned to its channel. The water receded. The mountains remained.